afternoon, pilot teachers, and good afternoon, students. Thank you. Sit down. Okay, we're going to continue on with our work on looking at planetary pressure belts and prevailing winds. In our last lesson, we looked at information on the major pressure belts and why they occur at the different latitudes. And today we are going to include the major planetary winds with that information on pressure belt. When we started off our lesson on pressure, we looked at three important points or key points. The first one is air will always rise, resulting in, or hot air, will always rise, resulting in a low pressure area being created. Cold air will always sink, resulting or giving rise to a high pressure area. Movement of air from high pressure areas to low pressure areas are referred to as winds. So winds definitely occur together with pressure. So therefore, after we have completed our work now on pressure belts, we are ready to look at the major planetary winds. So our lesson today will be basically looking at the major planetary winds around the world. We'll start off with our lesson by looking at what we have covered already. So let's revise. We revise on the major pressure belt areas. We should now or by now know why there is a low pressure in this region here. We should also know by now why there is a high pressure in the 30 degrees north and south latitudes. We should now know why there is a low pressure at the 60 degrees north and 60 degrees south. And we should also know why there is a high pressure in the polar or North Pole and the South Pole. We've gone through looking at the explanation of the different pressure belts already. There was a question that was also asked in our lesson yesterday. And the question was based on the reason for why, or is there a reason why this area here is referred to as the horse latitude? So for interest then, I'll read to you something that is actually found from one of the books explaining the reason for why that area, 30 degrees north and south, is actually referred to as the horse latitude. It tells us here that the surface pressure, those are the different pressure belts that we are looking at, and also the wind systems that we are going to discuss in our lesson today, have traditional names which come from the era of sailing vessels during the 17th through to the 19th centuries. So the major pressure belts plus the prevailing winds that we are going to look at today, they have traditional names, and those names have come from the era of sailing vessels during the 17th through to the 19th centuries. The subtropical highs, that is at 30 degrees latitude, which is the belts of descending warm, dry air, fair weather, and weak surface winds, are often called the horse latitudes. Why? One of the students asked yesterday, why are they called the horse latitudes? Legend has it that when ships becalmed in these latitudes, the horses were the first to go overboard when supplies of food and fresh water dwindled. So obviously, sailors traveling perhaps from Europe into Africa and perhaps to America would be carrying horses with them. By the time they would reach around 30 degrees latitude, especially in the northern hemisphere, what happens is that this area is an area of no surface winds or hardly any winds blowing, due to the fact that air sinks, and when air sinks, it is associated with dry conditions and also stable conditions. So the ships travel to around this area, 30 degrees north, and then they cannot actually move because at that time, the ships would be sailing, and they would need the winds to actually take them from point A to point B. So they came to these areas and they stopped. And after a couple of maybe days or weeks even, then what happened is that their food supply or water supply starts to run dry or run out. So in order to maybe try to ensure that there is enough supply of food and water, especially on their ship, they would have to get rid of some of the bigger items that they are carrying with them. and the horses were the first to actually get to be thrown overboard around those latitudes. And that's the reason, according to information here, legend tells us, and that is the reason for why the 30 degrees north and also the 30 degrees south are referred to as the horse latitude. Okay, a student asked about that, so I thought we might also look at that. Beside the reason given on meteorologists, similarly, when they are trying to cite, or when they cite the movement of air masses, especially cyclones, the first meteorologist to actually cite the cyclone would usually have that cyclone name after that meteorologist. Say, for example, Cyclone Helen. Helen might be the first person to actually cite this particular. Helen, in the sense that she is the person in the station being the first to cite the movement of the air resulting in a cyclone being developed. Therefore, the cyclone could be named after her. Okay, we move on. Pressure is also associated with winds. Winds can actually be seen in a local scale, say, for example, our local winds that blow, and winds can also be seen on a large scale, or what we call a planetary scale. We have looked at information on pressure belts on a large scale, and together with those pressure belts, then we are going to look at the major planetary winds. We already have learned that winds will always blow from high pressure areas to low pressure areas. So if we have to include the major planetary pressure belts and the winds, then our diagram showing us the direction of the major planetary winds would look like what is actually shown here. This diagram shows us how the winds would blow on a non-rotation Earth. We start off at the Doldrums. The Doldrums is a low pressure area. Air rises from the Doldrums. It would sink around 30 degrees north and south. The sinking of the air at 30 degrees north and south would create a high pressure area. Some of the air which has actually sunk about 30 degrees north and south would travel back as surface winds to the equator or the Doldrums. So the first group of winds now that we can actually look at would be those air masses that are actually blowing from the 30 degrees north and south back towards the equator. Here is a major planetary wind system from the 30 degrees north to the equator, 30 degrees south to the equator. Why? Winds blow from high to low. The second group of winds then would be those that blow from the high pressure up towards the North Pole and from the high pressure towards the South Pole. But before they reach the North and the South Pole, they would come to an area of low pressure belt. And that low pressure area, 60 degrees north and south, we already know is created as a result of the meeting of the warm air and the cold air, resulting then in the rising of the warm air, giving rise to a low pressure belt. So here at the North Pole and the South Pole, they have high pressure belts. And we already mentioned that winds will always blow from the high pressure to the low. So from 90 degrees north to 60 degrees north, winds will blow from the north to 60 degrees north, and winds will blow from the 90 degrees South Pole to the 60 degrees south. And again, our rule still remains, winds will always blow from high pressure to low pressure. Okay, we look at the diagram on the board now, and this diagram has both the pressure belts and the winds, the major planetary winds. These winds here are excluding the local winds that we have. We will discuss the local winds later on. The ITCZ, we still remember what ITCZ stands for? Yes? Renagi, what does ITCZ stand for? Renagi is going to tell us what these initials stand for. No? Okay, someone will have to help Renagi. Tell us what ITCZ stand for. Otherwise, we have the initials here and we have no idea what this is representing. Silo? Okay, Silo?
ITZ stands for Intertropical Convergence Zone.
Okay, good. So make note of that. The Intertropical Convergence Zone. Or in other words, this is also known as the Doldrums. Okay, here we already found out air rises simply because it is hotter here at the Doldrums. When the air rises, it will go to about 30 degrees north and south before it sinks. The sinking of the air at 30 degrees north and south would give rise to a subtropical high pressure belt, which is referred to as the host latitude. Some of the air which actually sinks around 30 degrees and 30 degrees north and 30 degrees south will have to travel back to the equator because our rule states that winds will always blow from high pressure to low pressure. So here, the winds which are found between 30 degrees north to the equator and 30 degrees south to the equator are referred to as the trade winds. Okay, so trade winds are winds that are found between 30 degrees south to the equator and 30 degrees north to the equator. So the winds on a large scale that blows in these latitudes are referred to as the trade winds. We can give them specific names according to the different hemisphere. And if we have to give the specific names, then we must also remember that winds always are named according to the direction from where they blow. So we start off with the 30 degrees south to the equator. The trade winds here are referred to as the southeast trade winds. Okay, so the southeast trade winds in the southern hemisphere from 30 degrees to the Doldrums. In the northern hemisphere, from 30 degrees to the Doldrums, we have the northeast trade winds. And I'll explain to you later on why is it that we are saying northeast and southeast. Okay, so these are the first group of major planetary winds. The second group of major planetary winds are those that blow from the 30 degrees south to 60 degrees south and 30 degrees north to 60 degrees north. These winds here found between those latitudes are referred to as the Westerlies. In the southern hemisphere, it is also known as the Westerlies. Remember, I mentioned that winds are named according to the direction from where they blow. So if the winds, the Westerlies in the northern hemisphere, what do you think if we had to add in the direction from where they are blowing to the name? What do you think would be the correct term to describe the westerly winds in the northern hemisphere? Ebony, what do you think?
Northwesterly winds.
Northwesterly winds in the northern hemisphere. Look at the diagram here. Yes? Ovio?
The northwesterly winds.
He still says that they are the northwesterly winds in the northern hemisphere. Gideon?
The southwesterlies.
Yeah, definitely it would have to be the southwesterlies because you see, where are they coming from? They're coming from the south, blowing in that direction. Remember, I told you winds, the major planetary winds are actually named according to the direction from where they blow. Here, look at these winds here. They are called the southeast trade winds. They're coming from the south. Therefore, they are called the southeast trade winds. The winds here, between 0 to 30, they are called the northeast trade winds because they are coming from the north. Similarly, the westerlies. In the northern hemisphere, the westerly here is referred to as the southwesterly. The reason being that it's coming from the south direction. Whereas in the southern hemisphere, The westerlies would be referred to as the northwesterly because they're coming from the north direction. Okay? So the second major group of winds now are the westerlies, and the westerlies are found between 30 degrees and 60 degrees north, 30 degrees, 60 degrees to the south. Finally, the last of the major groups of wind or planetary winds are the polar winds. In the northern hemisphere, from the high pressure belt to the low 60. Blowing from high to low, we have the polar easterlies. That's in the northern hemisphere. In the southern hemisphere, we have from the high pressure belt, which is 90 degrees south, to 60 degrees, which is a low pressure belt. And the winds here are referred to also as the polar easterlies. Any questions or queries? No questions? Okay, I'll give you time now to make note of this information. And after you construct the diagram, I would like you to be able to also name the major planetary winds and see if you can see the relationship they have together with the major pressure belts that we have looked at already. So into your exercise book, an activity now for you to work on, you construct a circular diagram, and your circular diagram should show the major planetary winds. But always remember, winds will blow from high pressure areas to low pressure areas, number one. Number two, most of the planetary winds are named according to the direction from where they blow. I'll give you at least about 7 to 10 minutes for you to construct your diagram. Okay. So by the time we come to the North Pole and the South Pole, they are the furthest extent of our latitudes. So there is no other way except from the poles we have to blow back towards the equator. So they are called polar easterlies simply because winds in the northern hemisphere and the southern hemisphere, they tend to deflect. And the deflection of the winds and the ocean currents and all those are basically referred to as the Coriolis effect. And that is the next information that we are going to look at. If we know, first of all, the names of the main planetary winds, then the next thing that we'll move on to is we're going to look at the fact that the winds, they don't blow straight up, straight down. No. They are always deflected to either the right or to the left because of the rotation of the Earth. And the rotation of the Earth, when it causes the deflection of the winds in the different hemispheres, is referred to as the Coriolis effect. And that's what we'll come to first. Okay. But if you look at the North Pole and the South Pole, there's no other direction now except from the north it will have to come down to the south, and from the south it has to go to the north. There's no other direction that we can go. But because of the deflection, they are deflected to the left, and that's what makes them easterlies, because they are going to the east to the west, and therefore because they are deflected to the because the deflection is to the left, if it's deflected that way, then obviously this is west, right? And this is east, and that's why they are called out polar easterlies, because winds will always blow from the direction of the east. Okay, maybe I'll have your attention and we'll go through what we have covered in our lesson today, and I'll give you the rest of the time then for your homework to complete the diagram showing us the major planetary prevailing winds. Okay, what we have covered so far today is we've looked at generally the major prevailing planetary winds. These winds here, the polar easterlies, the westerlies, and the trade winds, they are actually what we call planetary prevailing winds. The reason for why they are called prevailing or planetary prevailing winds is because they blow right throughout the year. And the winds that are the major planetary winds, they are according to the major pressure belts that we have already studied or looked at. To recap on what we have done, we looked at the winds that blow from the 30 degrees horse latitude to the doldrums are referred to as the trade winds. In the northern hemisphere, they are known as the northeast trade winds. In the southern hemisphere, they are known as the southeast trade winds. Here in Papua New Guinea, we are in the southern hemisphere, and we do hear a lot about the southeast trade winds. Okay, then we have the winds which blow from 30 degrees to 60 degrees in the north and also in the south. These winds here are referred to as the westerlies, the major prevailing winds referred to as the westerlies. Then in the northern hemisphere, from the 90 degrees north pole to the 60 degrees, similarly in the southern hemisphere from the 90 degrees south pole to the 60 degrees, we also have the polar winds or the polar easterlies. These then are the major prevailing planetary winds. Those winds are developed as a result also of the major pressure belts. If it were not for the rotation of the Earth, if the Earth did not rotate, this is how the planetary winds would look like. From the equator, winds actually would blow from, not from the equator, winds would usually blow from the horse latitude straight back to the equator. Similarly, in the southern hemisphere, from the horse latitude straight back. In the northern hemisphere, the westerlies, they would be blowing straight up. Similarly, in the southern hemisphere, the westerlies blowing straight down. And then the polars would be blowing from the high to the low, straight up or straight down. And in the southern hemisphere, from the high to the low, straight up. But winds in reality do not blow straight up and straight down in the different hemisphere. And in our lesson tomorrow, we are going to look at what we call the Coriolis effect and how the Coriolis effect has an influence on the direction and the deflection of the winds in the different hemisphere. Check your exercise books and show that when you are constructing your diagrams to show the planetary winds, that you correctly also indicate from which direction the winds would be blowing from the southern hemisphere between these different latitudes as explained. Okay, and your homework is to complete your construction. With that information, that will also bring us to the end of our lesson. Okay, class, if you can stand up now, please. To the pilot teachers, our keyword for lesson 119 is trade winds. Good afternoon and thank you, students.